You know how I was able to reproduce this phone from my house into Fusion 360. So I started by making this shape right here. By making a rectangle and then making it thicker. And then the next step was adding another layer of thickness, a rectangle shape right here. And then I added the buttons on the phone. The buttons for the numbers 1, 2, 3, 4, 5, 6, 7, 9. And then lastly, last but not least, I added the screen. And writing for the name of the company, and I added numbers by simply just writing the numbers and then playing around with the thickness of it. Which gives us our final result, which is this right here. Next thing that I modeled is actually this laptop, this whole thing. This is where I make music, this is where it all happens, and you know, I just thought I'd model this laptop just for fun. And here's what I ended up having right here. Very, very simple. I just did like a quick sketch. And for this, it started off simply by drawing the screen first, I believe. No, actually drawing the base for the laptop, where the laptop actually sits. So this part right here, this platform. And then after that, this next part was pretty tough. Drawing the curve that connects the screen to the base of the laptop, you have to first draw a line, and once you draw a line, you have to draw the surface which is gonna be rotated over that line, this is basically calculus, you know, finding the area of a curve. And then this is what we got right here. And then from this, we just simply attached the screen to it. We just simply attached a square to it, and then we made it thicker. And then we got this. We got this. And I could obviously improve and add some more things, but I don't know. I felt like I was satisfied with what I came here. I would be tempted to add the Mac logo sign, add a circle here for the camera, and add a keyboard on top of it, so it's all good for now. The next thing I'll be modeling is this right here, this little keys accessoire that we have in our house. I'll be modeling this in Fusion 360. This is the result I was able to get in Fusion. Now let me show you how I got it. First off, there's this tool that lets you just draw letters on Fusion. So I started off by drawing these letters, and after that I connected them by drawing a rectangle that connects them together. And then after that I drew a small rectangle on each letter like this that is connected to this axis right here. And then after doing this for each letter, you get this. And finally, I attached it was kind of tricky, but I attached a loop to each rectangle that I previously made. This was kind of tricky. I had to draw a circle here and then make this shape connect to this rectangle. method. First, we have scamper method. This was used for the density function to pick out which density was going to represent the best the fire in the forest fire. Then we got pros and cons. This was used for the energy function. You see, the energy function could have been described in 3 ways: the battery life of the drones, the distance traveled by the drones, and also the operation time of the drones. And this method helped us for that. And then SWOT analysis helped us pick which algorithm would be best for this situation.
So using Lloyd's algorithm, you considered 3 different drones. The first one was the MQ-9 Reaper, the second one was called Wild Hopper, and the last one called the Ariel.
So for concept selection, we began with a design criteria that took into consideration all the considerations, and then 3 potential solutions were researched. Then there was an evaluation matrix which included the cost, safety, efficiency, battery life, and extinguisher capacity of each of the drones. And then we came up with the final solution of the MQ-9 Reaper.
So our final design consists of a fleet of surveying drones which respond to unusual ground sensor activity and confirm whether or not a fire is present. If a fire is present, it signals for the extinguishing drones to come, as well as alerting the local fire station. And all the extinguishing drones will be pre-programmed with Lloyd's algorithm to ensure the optimal suppression of the fire. Additionally, the budget was reduced by up to 25% by using drones, which allowed for us to buy their drones, which are costed at $16 million a plate.
The simulation was ran in MATLAB to represent how the drones were going to extinguish the fire. This simulation outputted 4 graphs. Here we got the arena plot, which represents the position and movement of the drones across time. Then we got the communication graph, which represents which agents are in communication distance from each other, and the sign points and coverage distance, the area that covered by the agent points.
Any questions?
Okay.
So here, as you can see, we finished soldering all the components, and we connected. This is the connector right here, where we connected a negative 15 volt source and a positive 15 volt source and a ground source to the breadboard right here. So we have the ground source, bottom, negative 15 and positive 15. And we use the oscilloscope to get our data, which is connected to a software which prints out the data in graphic form.
So me and shoulder robot like this. It's a robot that shoots. Yeah. But there's no bullet currently. Yeah. We're not allowed to shoot anything here. Yeah.
I think my dad wants to put this like on top of it, the products that he will be manufacturing. How I got here, let's see, I don't even know what I did. Yeah, made a square, and then I lifted it up. Okay, so I obviously imported this right here. And then the part that I missed is that I imported it as like a sketch, and then like the 2D version, and then the 2D version I turned it into a 3D model by extruding it, and then I moved it onto the platform, onto here. And then I added holes.